All right, stats students, this is going to be our final video for this second chapter of our first unit. We have been talking a lot about normal distributions and how to solve problems involving data that is normally distributed or approximately normally distributed. Now, what if our data is not normal? So sometimes you can make a guess based on experience about whether a distribution is normal or skewed, but that's generally not a very good idea. So typically, things that could be normally distributed, SAT scores, state unemployment rates, gas mileage for your personal vehicle, right? Data that's going to be generally skewed, personal income for, Americans, number of children per family, that's generally going to be skewed, probably skewed to the right. So you can kind of have this guess, but you don't want to just guess because you can't use these normal strategies unless you have more evidence. So there's a couple different tests that you can do to see if data is normal. What you can do is you can take your data set and see if the data falls into the empirical rule, the 68, 95, 99.7 rule. The other option is to create something called a normal probability plot. Normal probability plots are constructed by plotting each observation in the data set against its corresponding percentiles z-score. So you can see here there is a clearly skewed histogram, skewed to the right, of survival time in days, and then converting those values into their z-score. So remember, a z-score tells you how many standard deviations from the mean it is. We have this graph here, okay? If the data had been normally distributed, this should be approximately linear. So normal probability plots aren't officially an AP topic, so you would never be asked to construct one from scratch on an exam, but they can be used on the test to show normality. Other times they might show you a graph of a normal probability plot and ask you to interpret it. So you never have to create one, but you might need to use one. If your data is approximately normal, the line of the normal probability plot should be approximately linear. So it is points, but the trajectory of it should be a straight line. So like I said, it graphs the distribution of the variable against its z-score. There is a way to do it on your TI calculator. If you go on page 136 of your textbook, it's explained there. Great thing about making this graph in your calculator, it doesn't matter which one you put on your x or your y axis. You can also use this with technology. There's a great website called staplet.com. I'll talk about that in a few slides. And that's a lot easier way of constructing one. Obviously, you wouldn't do that on a test, but it's good for your purposes of just figuring out if it is or not. The way you interpret a normal probability plot. So like I said, if the points on the normal probability plot lie close to a straight line, then the plot indicates that the data are normal or approximately normal. Systematic deviations from a straight line indicate a non-normal distribution. Outliers are going to appear as far away points that are, distant from the overall pattern of the plot. So you can kind of see that here. This is distant from the pattern. There are some examples in your notes, as you can see here. This is pretty symmetric. Maybe it's normal. And I see that it's basically normal. The distribution is approximately normal because the normal probability plot is approximately linear. Skewed to the right, you can see the points kind of taper off to the right. Skewed to the left, points are tapering off to the left. This is like a bimodal distribution, definitely not normal, and you can see it's got this little S curve to it. So it can be a bit of a science to read these, but the more you do it, the better you get. Let's do an example together. The measurements listed below describe the usable capacity in cubic feet of a sample of 36 side-by-side refrigerators. We want to know, are the data close to normal? When you're just given a set of data like this, we're going to kind of test two things. If we're not doing the normal probability route, let's go for the empirical rule. Before I even do the empirical rule, I want to get an idea of what does the graph of this data look like. So I used a website called Staplet and entered all the data in. And I made a histogram of the fridge capacities. I started at I think 12.8, 12.7, something like that. And it looks symmetric. It looks approximately normal. So we don't have reason to doubt that it is. But since I don't think that it's not, sorry for the double negative, I'm going to continue on and test the calculations. So putting that data either into my calculator or an online app, I can find that the mean is approximately 15.825 cubic feet, and the standard deviation is approximately 1.217 cubic feet. So now we need to use the empirical rule. The empirical rule says that 68% of the data is within 1 standard deviation of the mean, 95% is within 2, and 99.7% is within 3. So calculate where that would fall, and then literally count the data points and see how many of them, and then figure out the percentage, are within that range. So we can see that within 1 standard deviation, we have 66.7% of my data. Within 2, we have 94.4%, and then all of my data is within 3 standard deviations of my mean. So because these percentages are very close to the 68%, 95%, and 99.7% targets for a normal distribution, that, coupled with the graphical evidence, suggests that this distribution of usable capacity for these 36 side-by-side refrigerators is approximately normal. Yes, you have to say all those words. Notice how I use context here. I was talking about, the side-by-side refrigerators, usable capacity. I talked about the graphical evidence as well as the numerical evidence, and I showed that evidence. And then I used the word approximately normal. We're never going to say exactly, right? Everything here is an approximation. Now, what if you wanted to do the normal probability plot route to figure out how the normal probability plot looks? There obviously are instructions on how to do this in your calculator. I want to show you how to do it on a website as well. So there's a website called staplet.com. I love using this for the computer if I don't have my calculator handy. On that website, you would go to the part that says one quantitative variable single group. You enter in all your data, and then when it asks you what kind of graph type you want, you would just choose normal probability plot. This is the graph that we get. So the normal probability plot seems to be approximately linear. Give yourself a rough sketch of this on your notes, just so you kind of have it for reference. It doesn't need to be perfect, but a rough sketch will be helpful. So now if we need to do an interpretation, we would say that the distribution of usable capacity of these 36 side-by-side refrigerators is approximately normal because the normal probability plot is fairly linear. A common mistake that students make would be saying something like, it's approximately normal because it is linear. I don't know what you're referring to when you say it. So I'm saying the distribution is approximately normal because this normal probability plot is fairly linear. So just being super, super clear with what I'm referring to, avoiding using the word it. Okay? All right, that wraps us up for this section. So just a quick summary. We learned that normal distributions are described by a family of bell-shaped symmetric density curves called normal curves. The mean and the standard deviation are what specify the normal distribution using that notation. The mean is at the center of the curve, and the standard deviation is the distance from the mean to the change of curvature, which we call the inflection points. We talked how all normal distributions obey that empirical rule, which describes what percent of the observations lie within 1, 2, and 3 standard deviations of the mean. All normal distributions are the same when measurements are standardized, meaning when you find z-scores of them. It all goes back to the standard normal distribution, which has that mean of 0 and the standard deviation of 1. Table A gives us those percentiles for the standard normal curve. So by standardizing, you can use that table to determine percentile for a given z-score, or the z-score corresponding to a given percentile. Okay? We also learned how to use normal CDF in our calculator as well as inverse norm to replace table A there. And then finally in this video we talked about how to assess normality for a given data set. We look at its shape and then we check to see if it fits the 68, 95, 99.7 rule, or if there's a normal probability plot there, we can look at that. I'll never make you create a normal probability plot from scratch, but if I were to provide one for you, you should be able to use that to determine whether or not your data is approximately normal. All right, this concludes our videos for Chapter 2, and also then concludes our first unit on one singular quantitative data. Happy studying, work on your practice worksheets, and yeah, we'll do some practice in class. Hope you all are doing well.